Hello, here we'll start 4.3, which is talking about marginal functions. So 4.3.1 is talking about revenue and cost. Marginal revenue is the derivative of a total revenue with respect to demand. Okay, you already know what's the formula for total revenue. It's P times Q. You know that. Alright. So if our profit equals to 100 minus 2Q, and then we want our total revenue in terms of Q, so it will be total revenue equals to P times Q. That means this profit function is going to be multiplied by Q, so it will be 100Q minus 2Q squared. So this will be our total revenue. So here you have a note saying that marginal revenue is the derivative of total revenue. So to find marginal revenue, derivate this total revenue. So once you derivate it, what's the derivation of 100Q? It will be just 100 minus what's the derivative of this? Take the 2 down. It will be 4Q to the power of 1. So this will be our marginal revenue. Now if we current we want to know our marginal revenue if the current demand is 15. That means you're going to plug in 15 instead of this quantity. So marginal revenue equals to 100 minus 4 times 15 instead of the Q. As I told you, it will always be given how much is the demand, by the way. So the answer here will give you 40. So our marginal revenue is 40. Okay, you may be familiar with an alternative definition often quoted in elementary economics textbooks, which is saying that marginal revenue is sometimes taken to be the change in TR brought by a 1 unit increase in Q. TR is brought by what? By a 1 unit increase in Q. It's easy to check. So this is like another method of finding the marginal revenue, but it's not as specific as derivation. So derivation is more accurate and more specific, but this is near to the MR. You'll find a value which is near to it. So what's the method that we are going to use? It's a 1 unit increase in Q. So first let's say that our Q is 15. Of course you're going to go back to the original formula for TR, which we found it as 100Q minus 2Q squared. So you just plug in this 15 instead of the Q, because here we're not talking about a differentiation method. 15 squared. So once you evaluate this one using a calculator, you'll find 1050. So the total revenue once Q is 15 will be 1050. It's a 1 unit increase, so an increase of 1 unit in the value of Q produces a total revenue for the Q will be increased by 1 unit. That means here Q will be 16. So instead of the Q, I'll plug in 16. So once you evaluate this one using your calculator, you'll find 1088. So what's the marginal revenue? What's the difference between these two? Subtract them and you'll find 1088 minus 1050, and the marginal revenue will be 38. So if you remember, by the previous method we found that the marginal revenue was 40 and this is 38, so the number is going to be near to the previous marginal revenue, but not as accurate as the one that we found using the derivation method. So I'll give you like in a model, as I told you before. Once I was doing the derivative method, I found this black curve. Let's say that you have these 2 points, maybe this is 0.15 and this is my 0.16. So in the first derivative method I found this real black curve, but in the second one I was calculating a line slope. So always the line will be shorter than the curve, but they are going to be almost the same number, but not exactly the same. They will be like near to each other. Okay, I want you to try this question by yourself. If the demand function is P equals to 120 minus 3Q, find an expression for the total revenue in terms of Q. Find the value of marginal revenue at Q equals to 10 using the differentiation method, which is the first method. Second, using the 1 unit increase approach. So I want you to do both, and you can compare the difference in the results.